Hi dear students, now we are going to discuss about the electromagnetic field, unit 5. What is our unit 5 name? The electromagnetic waves. Now we are going to discuss about the waves of electromagnetic. Okay, discuss about the electric waves as well as the magnetic waves. So combination of electromagnetic waves. What are the objectives of unit 5? Understand the concept of electromagnetic waves and its characteristics parameters. These are the your fifth unit objectives. Now we are going to discuss about what are all the subtopics available in this unit 5. Okay. So derivation of wave equation in free space and dielectric, wave equation in phasor form, reflection of plane waves by a perfect dielectric at a normal incidence, wave polarization, linear polarization, elliptic polarization and circular polarization, pointing vector and pointing theorem. These are all the under the category of unit 5 in electromagnetic waves. So first we are going to discuss about the wave. First of all, define wave or definition of wave. It's like very important 2-mark question. If a physical phenomenon that occurs at a one place at a given time is reproduced at the other place at a later times, the time delay being proportional to the space separation from the first location, then the group of phenomena that is called as a wave. Then the second one, the Maxwell equation predict the propagation of electromagnetic energy. Once again, the Maxwell equation predict the propagation of electromagnetic energy away from the time varying sources. That means current and charges in the form of waves. Next, our first topic we are going to discuss about the three-dimensional wave equation, or otherwise this question asking another form of Helmholtz equation. First we are going to discuss about the assumption. First point, we consider the medium to be a linear or otherwise a homogeneous, that is a quantities mu comma epsilon comma sigma, so are a constant through the medium. The and isotropic, that is a epsilon is a scalar constant, so the d vector and e vector have everywhere the same direction. Second one, we consider a source, that means a free region of the medium. By a Maxwell equation, we are going to form a Maxwell equation in a free region of the medium. So del cross h vector, that is equal to j vector plus dou d vector divided by dou t. So the replace of the first equation we are rearranging. So sigma into E vector for electric field plus sigma into dou E vector divided by dou t. So take this equation number 1. Also from a Faraday's law, now we are going to discuss about the Faraday's law. Del cross E vector, I am going to take the same quantities because of mu comma epsilon comma sigma already given, you know. So there is no changes. So del cross E vector, that is equal to minus dou E vector divided by dou t, that is equal to minus mu into dou h vector divided by dou t. Take this equation number 2. So del cross E vector, that is equal to, because of 2 equal here available, you know. So del cross E vector, that is equal to minus of dou E vector divided by dou t, or otherwise del cross E vector, that is equal to minus mu into dou h vector divided by dou t. Then taking a curl on both sides, already we are discussed about the curl on first unit, you know, because of the del. So del into, what is in by both sides? LHS always RHS. So del cross del into E vector, that is equal to, here I am going to take it as a mu dou h divided by dou t, because of always equal, you know, dou B vector divided by dou t are equal to minus mu into dou h divided by dou t. So now I am going to take it as, so minus mu into dou divided by dou t into del cross h vector. Now applying, taking curl on both sides. So del multiple with both sides. Then using the identity, what is by using identity? So because to simplify the above equation, we are going to use it as the identity formulas. So above equation, del cross del into E vector, that is equal to del into del E vector minus del square E vector, because del into del square, you know. So del into del dot E vector minus del square E vector, that is equal to, because of we are going to write as electric field as one side, magnetic field as one side. So that is equal to minus mu into dou divided by dou t. So commonly we are going to write it as, so the sigma E vector plus epsilon into dou E vector divided by dou t. Now commonly take del dot E vector, that is equal to, we are going to substitute del dot E vector replace 1 by epsilon into del into D vector. We are going to rearrange in the above equation. We are going to get it as del square E vector minus mu into epsilon of dou E vector divided by dou T minus mu epsilon into, so substitute sigma as well as epsilon. Okay, so dou square E vector divided by dou T square, that is equal to 0. This is the three-dimensional vector wave equation or a Helmholtz equation in absorbing medium or a lossy dielectric medium. Okay. Thank you, students. This is equation number 3. Note it down. So this is a three-dimensional vector wave equation or a Helmholtz wave equation in a absorbing medium or otherwise a lossy dielectric medium. Both are same, you know. So absorbing medium or otherwise a lossy dielectric medium. Thank you.